Bismillahirrahmanirrahim. Assalamu alaikum everyone. So we are going to conduct another video tutorial for singularity signals, and we are discussing the various types of singularity signals available in the content of or in the context of signals and systems, right? So we have already done the tutorial on the basic definition signals, what are singularity signals. Then we actually learned about an important type, what was impulse function. And in this video tutorial, I'm going to talk about step signal, which is also important singularity function, right? Or important singularity signals, right? So let's see the mathematical definition or mathematical the representation of a step signal. So mathematically, it looks like this signal, right? So what does it say? First of all, it is usually denoted with u of t, and why it does, we will explain it later. So if you see this signal, this is a time signal dependent on the time, and its value is around a, right? So its amplitude is equal to a whenever time is equal to or greater than for 0, right? So this function is defined from minus infinity to infinity, and it actually has value or finite values which are defined equals to a, and those values are defined for the interval when time is greater than or equal to 0. So you can say that time values start, or the signal values start from 0 and goes to plus infinity. So in between these two points, you will have a value of signal which is equal to a. So for example, if this is an x-axis and this is a y-axis, and let's say amplitude a is equal to this value, so this is just a value which is equal to a, right? So this is we know that this is a time axis, and this is the value of the signal. So let's say it is our u of t. The value is basically u of t, and its amplitude will be equals to what? A, whenever time is equal to 0 or greater than 0. So you know that this is starting from minus infinity, starts somewhere from the minus infinity, and it goes to plus infinity, right? This should be the complete time domain. But usually we do have a limited signal. But if we take from minus infinity to plus infinity, so, and this is what time equals to 0, right? So this is time equals to 0. So signal will have a value equal to a, right? So its value will become eventually equals to a when time reaches to equal to 0, and later on, whenever whatever the value of the time, either it is 2, it is 1, it is 2.1, it is 100 or 1000, its value remain equal to a. So that should be the plot, or that should be the graph or graphical representation look like for a step signal, right? Why it is called step? Because it has only one value, and it's just have a step of it, right? So eventually, if you see for this interval, when time is less than 0, right? When time is less than 0, you see there is no value. So eventually, it does not have any graph available for this interval, right? So its value is 0. But when time reaches to t equal to 0, so eventually you will step it, right? So basically what has happened, it switches its value to another step, which is basically equal to a, and that is called amplitude of a. So this is a u of t whose value is equal to a. Okay, now let's talk about another variation of a unit step signal or a step signal, that is basically known as unit step. So this is the equation of unit step, and if you notice what is the big change, what is the big difference between the step and unit step, its amplitude or strength is basically equals to 1 here. So the value of the signal is 1 instead of a. A was a general value. So if there is an step signal whose value is equals to 1 whenever time is greater than or equal to 0, that means for this interval, if value of the signal will remain equals to 1, and elsewise it will be 0. So if I'm going to plot it, so it will look like something like this, right? So this is a signal which is plotted in a MATLAB environment, and I'm just showing you a graph of it here. So here time ranges starts from -3, right? And it goes to +8, right? This is the +8 position. So it starts from -3 and goes to +8. So if you see, this is the position where time equal to 0. So if you see the values between -3 and enter and 0, the value of the signal is basically equal to what? 0. You see, this is the y-axis, and in y-axis the value of the signal is what? 0. So this is the u of t, and its value is 0 before time equal to 0, and this is the instant when time equal to 0. So value switches from 0 to 1. If you see, this is the value equals to 1. So it value becomes 1 whenever when time is equal to become equal to 0. And if you go for greater than 0, so you will have a constant value which is equal to what? 1, right? So that's how this signal is basically a step signal, because it has a switch from 0 to 1 value. This is signal is normally referred as a DC signal as well, because this actually represent the DC or the constant signal in electrical and electronics application. So this is another important signal which one need to understand the complex signals. So that is why it is also included in singularity signals. So I hope you have understand the graphical and the mathematical definition of unit step signal or a step signal. Still, if you have any confusion, please post those confusions in comment section. I'll try to answer them. Thank you so much for listening.